All right, here we go. We're going to take some data for Investigation 5B, Part 1. I've got our sled here, like we talked about, and I've got a single photogate ready to measure the gate times. And as the sled goes down the track, of course, we expect the friction force will slow it down, and we want to measure how far it travels. That's what the extra meter stick is here for. The only data we record at this point is the photogate time and the sliding distance. Of course, from those two pieces of data, your task will be to determine the other things that we need. I've already pre-filled in the masses of the sled empty, and then +1, +2, and +3 ball bearings. So let's see how I do at launching. All right, let's just see if I can be consistent. My gate time is 0.0082, distance is about 25 centimeters. Let's see if I can do that a few times and get about the same thing. That was quite a bit slower. I have the stop set up here so I launch about the same each time. But again, as you see, it takes some practice, and that's okay. So we're going to go with this one as our first data point. Gate time is 0.0078 seconds, and I'm using the center of the car because I measured the speed at the center. So we're going to measure the center of the car, and it's looking like about 33 centimeters, which of course is 0.33 meters. So again, 0.0078 seconds and a distance of 0.33 meters. Now I'm going to add a single ball bearing to the center of the car. New mass, again, 0.0731 kilograms, and we'll take a run. Looks pretty good. Let's do another one just to see if I can be fairly consistent. Yeah, I'm happy with that. So now my gate time is larger. Notice 0.0095 seconds. Of course, that means the car probably didn't get going as fast. Hey, we've thought about that a while back, right? Yeah, think long ways back to when we examined that. But now the distance appears to be about 21 centimeters, or 0.21 meters. So you'll notice as we added more mass to the car, it seems like maybe the friction is a little more effective. Let's add another ball bearing, and let's try again. Couple of runs to see if we're fairly consistent. Yep, I'm happy with that. Now our gate time is 0.0113 seconds. So again, the cart isn't going as fast. And we are also seeing that the distance traveled now is about 15 centimeters, so 0.15. Now you might say to yourself, wait a minute, we're changing two things. We're changing the initial speed and the distance, and you're not wrong. However, because we're going to be able to tell the force from the work done, we'll still get what we need. All right, so here I am with 3 ball bearings added in. Our new mass is 0.1295 kilograms. And again, a couple of runs to look for consistency. That's looking like around 10 centimeters, around 10 centimeters. Yeah, pretty happy with that. Mr. Kozer's getting less good at this. All right, we're going to go with this one. So our data says our gate time was 0.0145 seconds. And it looks like our cart slid about 9 centimeters, so 0.09 meters. Okay, once again, here's a close look at that data, just in case you didn't catch it, so you can get that data recorded. And go ahead and capture that data if you're at home. Hopefully, if you're in the lab, you can capture your own data. And then move on to the analysis part. Of course, that's where you're going to determine the speed, the kinetic energy, and then we'll use those both to find the friction force.